Hey guys, so for this video I am just going to do a refresher on how to add, subtract, multiply, and divide mixed numbers specifically. I might throw in a couple examples where we do these with regular fractions because you might be seeing some of that too. And all of this you should be pretty familiar with, but this is just to refresh because we haven't done fractions for a little bit. So up here we're going to start with an addition problem. When you add two fractions or two mixed numbers, you have to find a common denominator. So this is where we usually do a t-chart, or we have talked about is one of the denominators already the common denominator, or can I multiply them to get the common denominator? So I can do the t-chart over here. 3, 6, 9. Oh, okay. So they have 9 in common. So I need to rewrite the fractions with a common denominator of 9. One of them already has that as a common denominator, so I'm going to leave it, but just rewrite it. So I need to multiply the numerator and the denominator by the same number. So 3 times 3 is 9. What I do to the bottom, I have to do to the top. So this fraction becomes 1 and 6/9 plus 1 and 1/9. And I'm going to go ahead and add those now because they have a common denominator. So 1 plus 1 is 2, 6 plus 1 is 7, and the denominator stays the same. So my answer is 2 and 7/9. You would do the same thing if you had just a fraction. So if I had, for example, 1/4 plus 1/2, I would find the common denominator. I know that 4 is the common denominator, so I need to rewrite it. So I know 2 times 2 is 4, and what I do to the bottom, I do to the top. So I would have 1/4 plus 2/4, and my answer would be 3/4. So that is just a quick example of how to do it with regular fractions. We are going to come over here and do a subtraction example. This is a bit of a challenging operation to do with mixed numbers, but I am going to walk you through it probably the easiest way. So we've talked about how you can just make both of these mixed numbers improper. When you are subtracting, you also have to have a common denominator. So you can make them improper, find a common denominator, subtract, and then turn it back into a mixed number for your answer because we can never answer with improper fractions. But before we kind of left, we had been doing a different method that is a little bit less work. I am happy with whatever strategy that you choose to use, but I'm going to show you just the one where you leave them as mixed numbers. So my first step would be to find a common denominator. So I can make a t-chart if I need to, but I know that 10 is the common denominator. So I'm going to rewrite these. So I leave 2 and 3/10. I'll be subtracting. I know that 5 times 2 gets me my denominator of 10. What I do to the bottom, I do to the top. So my new fraction is 1 and 4/10. Now, what you might be noticing is, well, I can do 2 minus 1, but I can't do 3 minus 4. I also can't just flip-flop the numbers and say, well, this is 2 and 4/10, and this is 1 and 3/10, and say, oh, 3 minus 4 is 1, or flip-flop them and say 4 minus 3 is 1. That is not the case. So what we have to do is, in this very first fraction, we have to borrow from the whole number. So I am going to borrow from it, and it is going to become a 1. 1 whole for this fraction is 10/10. So essentially, I am going to add 10/10 to this fraction. So I'm going to be rewriting this again. So it becomes 1, and 3 plus 10 is now a numerator of 13. My denominator stays the same, right, because we're adding and it has the same denominator. So now I have 1 and 13/10 minus 1 and 4/10. I know that I can do 1 minus 1. I know I can do 13 minus 4. So now I am going to go ahead and solve. 1 minus 1 is 0, so I have no whole number. 13 minus 4 is 9, and my denominator stays the same. So my answer is 9/10. When you are doing the IXL for this, don't forget to be putting in your slashes, so you'll be writing it like this, 9/10. Okay? Now we are going to come down and do a multiplication problem with these numbers. Hopefully you'll be able to see it okay. Okay, so I have 3 2/3 times 2 1/4. When I am multiplying mixed numbers, I have to make them improper. I can't do 3 times 2, can't do 2 times 2. I need to turn them into improper fractions, and then for my final answer, I will turn it back into a mixed number. So I make them add to make them improper. So I multiply, add, and then I'm going to rewrite. So 3 times 3 is 9, plus 2 is 11. My denominator stays the same. Now I have 4 times 2 is 8, plus 1 is 9. My denominator is 4. So now I have 99 twelfths. Obviously, that's improper. So to go from an improper fraction to a mixed number, I am going to be dividing. So I have 99 divided by 12. I'm just going to count by 12 so that I can see how many times it goes in. 12, 24, 36, 48, 60, 72, 84. I think it goes in 8 times. I'm going to check my work real quick. Yeah, because that gets you 96. So I'm going to put an 8 over the second 9, because obviously 12 doesn't go into 1 9. 99 minus 96 is 3. Now, 12 can't go into 3. It's not a decimal, so I'm not going to add on any zeros. So what I'm going to do is rewrite my remainder as a fraction. So I take my remainder as my new numerator, and then I take this number right here. Your denominator is always going to be the same. So I'm going to erase a little bit of my work so that you can see it. And my final answer is going to be 8 3/12. Yes, you can simplify. You don't have to. I don't believe on IXL you have to simplify if you come across that. I could be wrong. I haven't done it on IXL. But to simplify, you would just find a number they have in common and divide to make the fraction smaller. All right, last but not least, we have division. So with division, we do KCF. You keep, change, flip. Okay, so I am going to keep 4 1/2. Okay, first thing I'm going to do is I'm going to make it improper. I'm going to rewrite. So I know that when I have a whole number of 4, sorry for the long pause. With the 4, as a whole number, I know that it is always over 1 as a fraction. So I'm going to make this mad. I'm going to change the division symbol to multiplication, and then I'm going to flip 4 over 1. And so by making 4 1/2 mad, I'm not changing the number, I am keeping it. I am just turning it into an improper fraction. So I have 9 over 2. Now I change to multiplication and I flip it to 1/4. And now I can multiply. So I knew I was going to end up changing the operation of multiplication, and I knew it had to be an improper fraction to do the multiplication, which is why I did it here. You could rewrite it and then turn it into an improper fraction in that order if that's what is easiest for you. So I'm going to multiply now, and I get 9 eighths. Obviously, that is an improper fraction, so that can't be my answer. So I divide when I have an improper fraction. This example you might be able to do in your head, but I know 8 goes into 9 one time. 9 minus 8 is 1, so I have 1 1/8 as my final answer for this division problem. And please notice it did get smaller, so that is how I know that this is the correct answer. If you have any questions, please just message me on Google Classroom. If you are still struggling with one of these and you're just getting super stuck and super frustrated, I am happy to do a Zoom call with you too, just one-on-one, to kind of go over some examples and to have you ask questions a little bit easier. So if that is something that you're interested in, then please just let me know. Bye, guys.